fourth model we want to go over is a logistic growth model. Some populations have rapid growth followed by a declining rate of growth. So, if you move into an area around Indianapolis, like Fishers, Hamilton, Southeastern area, those have a large rate of growth. And then eventually what's happened is they've just kind of declined a little bit. One model for describing this type of growth is a logistic curve. And like I said before, you're not going to have to memorize this formula, but it helps if you know what it looks like. So this is a logistic curve. Y is your population size, X is your time. So if you notice here at the beginning, you have an increasing rate of growth, and then what happens, you reach a point where you're not increasing or decreasing, and then the other half of your graph, you're decreasing. So you reach a point where you're neither decreasing or increasing, that's halfway up your curve, and then your other half is going to be your decreasing rate of your growth. So on 5, what we have here is a college campus of 7,500 students. One student returns from vacation with a contagious and long-lasting virus. Oh, disgusting. The spread of the virus is modeled by this equation: y equals 7,500 over 1 plus 7499 base e to the power of negative 0.9t. T is greater than or equal to 0, where y is the number of students infected after t days. The college is going to cancel classes if 30% or more are infected. So, we need to figure out how many students will be infected after 4 days. Well, that's not too bad. All we got to do here is just plug in y equals 7,500 all over 1 plus 7499 e to the negative 0.9 times 4. And we just plug this into our calculator. So we plug this into your calculator. Let's get rid of our Gaussian model here. We're going to go 7,500 divided by, and you need to put this in parentheses, 1 plus 7499 base e to the negative 0.9 times 4. So after 4 days, oops, I don't need that again, in parentheses, after 4 days, you're going to end up with 36 students, 36.4, so that other 0.4 must be really short. You're going to end up with 36 students infected after 4 days. That's not very nice. Not very nice of that person to bring back that virus. Let's hope you're part of the other 74, or 64, I guess. Okay, now after how many days will the college actually cancel classes? So we want to figure out 30% of the population. So when we set up B here, what we're going to need to do is we're going to have to take 30% of our original population. So we're going to have to go 0.3 times 7,500, and we're going to have to figure out what our t is. So we're going to have 7,500 here, all over 1 plus e to the negative 0.9 times t. Whoops, I forgot my 7,400 on the bottom. That might make a little difference. And I will apologize if the bell rings here in a little bit. I'm just working overtime for you guys. E to the negative 0.9t. So let's simplify. 30% of 7,500. That's 2,250. And what we have then is a proportion. And you guys all know how to solve proportions. You had to do that a couple times on your homework, your last homework. So if this is over 1, we just cross multiply. And then we're going to multiply these. So we end up with, let's see, 2,250. There's the bell. It's about quitting time. Negative 0.9t equals 7,500. And don't distribute the 2,253. You can if you want, but I think it's going to be a little bit uglier if you do that. Let's go ahead and just divide both sides by 2,250. I'm going to get some ugly, numbers here. So we're going to end up with 1 plus 7499 e to the negative 0.9t equals 7,500 divided by 2250. That's a 3.3 repeating, so we won't change that yet. So let's just leave this at 7,500 over 2250. I don't want to make that a 3.3 yet because that just means you're going to be abbreviating, which is going to keep, it's going to make your answer a little bit not as precise in the end. So next thing we need to do is we need to subtract 1. Dang it, it's supposed to be in purple. So subtract 1 minus 1. And you get 74. This is going to be awesome to plug into the calculator. E to the negative 0.9t equals 7,500 over 2250 minus 1. And then we're going to have to divide all this by 7499. Wouldn't it be easier if we would have just divided at the beginning and simplified this over here on the right? That would be easy. But that is not what I'm about. That's not what pre-calc's about either. So we're going to have e to the negative 0.9t equals all this. Oh man, 7,500. I cannot wait to plug this in. I just want a precise answer. 74.99. Now in order to get rid of a base e, we need to natural log both sides. And when you do that, almost done. Negative 0.9t equals, I hope this is right, and in parentheses 7,500 divided by 2250 minus 1 all over 74.99, and all this just has to be divided by a 0.9, negative 0.9. Gee, thought this was going to be difficult. So let's figure out what t is. I'm so pumped. So we're going to say, well, the natural log of 7,500. Oh wait, we're going to need to put this in parentheses. So we're going to take 7,500 divided by 2250, and then that's going to in parentheses there. And we're going to subtract 1 from that. Now we're going to need another parenthesis because we're going to have to evaluate this top. So I'm going to have to add a parenthesis over here in front, another parenthesis in front of my 7,500. Maybe. So I'm going to insert a parenthesis, second insert, in parenthesis. And all this has to be divided by 7,400. Divide this by 7,400, 74.99 to be exact, in parentheses, because that's going to find our natural log. And then all of this, the entire thing here, is going to end up getting divided by a negative 0.9. So, excellent. Approximately 9 days later. So good news is you still have about a week and a half here to enjoy your life and not be infected. That's a lot of work just to figure out how long you can be until you're infected. I would probably just wait it out. You know, maybe just stay inside, play a little Call of Duty or something like that. Just don't go to the store, don't go to class. I wouldn't recommend doing any of that. All right, fantastic. Nice job, guys.